Alright guys, now we're going to start talking about bearing number systems, okay? So we're going to talk about a complex number system, which includes all possible numbers known to man, okay? Let's talk about some of the more elementary subsets of that complex number system, starting with the natural numbers, those which you learn when you were a child. 1, 2, 3, 4. Ellipses here. Ellipse means it carries on to infinity, right? Okay? Uh, Putting zero in there was actually a big milestone. The concept of zero took centuries to evolve, and so it deserves a whole classification of whole numbers. Okay, integers, of course, come in when we have to deal with negatives. Okay, all these sets are infinite in nature. Integers are, of course, infinite going in positive and negative infinity, as you should well know. Okay. Rational numbers is pretty much what we think of as fractional. Very, they can be expressed as a fraction a over b, b not equal 0, a and b both being integers, okay? Things that can't be expressed as a fraction are irrational. Things like pi, things like root 2, things like root 3, okay? Grade school might have told you that, oh yeah, use pi as 22 sevenths. That's a rationalized expression close to pi. It's not pi, just like 3.14 is not pi. And irrational numbers are left alone. Okay, if an answer is 5 pi, it's 5 pi. If the answer is root 2 or 2 root 2, it's 2 root 2, not a decimal approximation. Okay, real numbers, of course, then comprise all these, as Bill, and is I usually think of it as the union of the irrational and the rational numbers. Okay, it's kind of best illustrated over here. Real numbers are union of irrational numbers and rational numbers. So all irrational numbers are reals, but not all real numbers are irrational. Okay, and then the rationals, of course, break down into those given subsets. Okay, whereas each number system is a subset of the number system above it. Each number system is a subset of the number system above it, okay? But that's not the end of it, because uh, on the one branch from the previous slide, we had the real numbers, okay, expressed as a over b, a and b integers, b not equaling 0, and that was it. But now we have another branch known as the imaginary. The nature of what is I is the square root of -1, okay? Um, and anything that involves a square root of a negative is effectively going to be expressed with I, as we can see here. The square root of -4, undefined in real number systems, but in imaginary number systems, it is the square root of 4 times the square root of -1, which is 2I, okay? The square root of -3 becomes the square root of 3i, or I root 3, okay? So when we look at the union of the imaginary and the real, we have the complex. And a complex is a number which can be expressed in the form a plus bi. A plus bi, where a and b are real numbers and I is the imaginary number. Of course, a number like 3 can be expressed like this, because it could be 3 plus 0i, okay? A number like the square root of -4, otherwise known as 2i, is effectively 0 plus 2i. So, okay, even though it may not be expressed in this form, it can be. So any number that you can think of, 2/3, is 0 plus, 2/3 is 2/3 plus 0i, okay? So any number you can think of can be expressed in this form. We've got to talk about dealing with I, and here we go and remind you of the powers of I, of course, I is the square root of -1. So I squared is the square root of -1 squared, okay, which is the square root of -1 times the square root of -1, which is the square root of 1, or 1, okay? I cubed is the square root of negative 1 cubed, okay? All right, which can be expressed as uh, I squared, okay, and the square root of negative 1, which is I. So this is breaking this down as I squared and I, okay? And of course, the square root of negative 1 is I, and I squared, as we saw up here, is 1. So this is negative I, okay, is I cubed. I to the fourth is I squared times I squared, negative 1 times negative 1, which is, okay, 1. So basically, anything of a power of I can be reduced to one of four things: I, 1, negative 1, or 1. I, 1, negative I, or 1. So, I to the fifth, following the trend, is I. Because why? Because it's I to the fourth times I. I to the fourth is 1, so it's I. I to the 11th is what? I to the 11th is, okay, well, you have to find a power of 4. So this is I to the 8th times I to the 8th times I cubed. I to the 8th is I to the 4th squared, so that's 1. So this falls to be the same thing as I cubed as negative 1. As an example over here, the 57th power of I. I want to break that down into either I squared, I cubed, okay? And then I want to break it down into powers of 4. Well, powers of 4, 57. I know 56 is 9 times 4. So the following trend is how I break that down. I rewrite it as I to the 4th, as I to the 56 times I, which is I to the 4th to the 9th power times I to the 4th, we know is 1. It's 1 to the 9th. 1 to any power is 1 times I. So that's I. So that's resolves to that. Okay. Now we talk about operations with complex numbers. And it's basically down here, as I said, add or subtract the real number component and add or subtract the imaginary component. So 3 plus the complex number 3 minus 6i. There's only, both numbers have a real number part, okay, which we add, and there's only one imaginary part, so 6 minus 6i. The imaginary number 2i plus the complex number negative 3 plus 5i, they have, both have the imaginary component, so we add the imaginary component, and the real component is left as is, okay? Now we have the sum of two complex numbers. We add the real number part of 4 and then minus 7, okay, and then we add the imaginary numbers component, negative 3i minus 2i over here. And of course, this gives us negative 3, and this gives us, okay, negative 5i. That's our resultant complex number from the sum of these two complex numbers. Multiplication of complex numbers is a bit more involved, and invariably, for more sophisticated one, involves the FOIL method. Things like 3 times the complex number 3 minus 6i, we simply distribute the real number over each part of the complex number, and we get 9 minus 18i. Likewise, 2i, the imaginary number, times this complex number, okay, which is 2i, distribute 2i times negative 3 is negative 6i, and 2i times 5i is 10i squared. Of course, I squared, we should remember, is negative 1. So that's shown here. That just goes to negative 10, which becomes negative 10 minus 6i. Again, we typically keep the imaginary part of the complex number written second. Okay. The product of two complex numbers is done via the FOIL method. That's outlined down here. First, outer, inner, last. First with the first, 2 times 3, okay, as you see, 6, okay, outside 2, 2 times 4i, 2 times 4i is, of course, 8i, all right, and then the inner 2, negative 6i and 3, negative 6i is 3, is negative 18i, and then the last, which is negative 6i times 4i, okay? And negative 6i times 4i is negative 24i squared, okay? So we're down to this stage. That's not simplified because, of course, 8i minus 18i is negative 10i, and negative 24i squared, I squared being negative 1 times negative 24 is plus 24. The resultant complex number, 30 minus 10i. Okay? Let's go through the division and we'll call it quits for this video. Okay? Division of complex numbers. Division of complex numbers introduce, okay, what's called the conjugate. Whereas we said a complex number is of the form a plus bi, its conjugate is a minus bi. So a plus bi and a minus bi are complex conjugates. Okay, this quotient of 6 minus 2i over 2i, okay, is effectively asking you to divide by a complex number, which for all intents and purposes is like dividing by 0. You try to avoid it. Okay, and the way we avoid it here is we multiply everything, the original expression, by 1, and by 1 in the form of the conjugate of the denominator over itself. Conjugate of the denominator over itself. That's 2i is my denominator, its conjugate is negative 2i. And we put that over itself, which is 1, which is not changing the form of anything. It's changing the form, but it's not changing the value. Okay? And then we execute the multiplication much the same way as we showed you on the previous slide. Okay? And sorry about that. Okay? Distributing upstairs, and then down below we get negative 4i squared. It's negative 4 times negative 1, which is 4. Okay? And then we finally result this into a complex number down here, negative 1 minus 3i. Here is a complex number 2 plus 3i divided by divided by 1 minus 4i. Again, the division becomes multiplication with the conjugate. The conjugate is 1 plus 4i, because all we do is change the sign of the denominator over itself. We carry out the multiplication upstairs using FOIL method. Likewise down below in the denominator using FOIL method. We recall we're going to get an I squared term there, which is I squared being negative 1. We link our like terms together, and we get negative 10 plus 11i over 17. That is not a complex number. Complex number then is, okay, a real component. In this part is real. It's, again, it's fractional, which means it's a rational expression, and a imaginary expression. Okay, so this would be the accepted form of that answer. Okay, so that'll do it for our discussion on complex numbers for now. Okay.